Here in question they have given the bromine atom possesses 35 electrons. It contains 6 electrons in 2p orbital, 6 electrons in 3p orbital, and 5 electrons in 4p orbital. Which of these electron experiences the lowest effective nuclear charge, they are asking. So bromine atomic number is 35. Bromine atom possesses 35 electron means they are giving bromine atomic number is 35. If you write electronic configuration, you will get this. So in 3p orbital 6 electrons are there, they are telling, and in 2p orbital 6 electrons, as well as in 3p orbital also 6 electrons, and in 4p orbitals also 6 electrons they are telling. Which of these electrons experiences lowest effective nuclear charge? So you see here 2p6 means it is second shell, 3p6 third shell, 4p6 is a fourth shell. This is nucleus, this is first orbit, this is second orbit, and this is third orbit, and this is fourth orbit. Which is very close to the nucleus that will experience more nuclear attraction force, or that electrons will be experienced more nucleus attraction. When number of shells will increase, the nucleus attraction force on that electrons will be decreased. Why? Because the distance from nucleus to valency shell will be increased when n value increases. Means here second shell is very close to the nucleus, means it will experience more. Means 2p6 electrons experience more nucleus attraction, as well as 3p6 will experience less comparing with 2p6. So this 4p6 will experience less comparing with 2p6, 3p6. So that our answer is 4p. 4p orbital will experience lowest effective nuclear charge. So that we have to take 4p as answer. Go for next question. Among the following pairs of orbitals, which orbital will experience the larger effective nuclear charge? 2s and 3s, 4d and 4f, 3d and 3p. So here, among the following pairs of orbitals will experience the larger effective nuclear charge. Which one will experience larger? So you see here 2s and 3s they have given, 2s and 3s. In this 2s and 3s, 2s is very close to the nucleus and 3s will be away from the nucleus. Why? Because when n value increases, distance also will increase from nucleus and that shell. So that's why here 2s will experience more. Here 4d is there and 4f is there. So comparing with the d orbitals and f orbital shape is four-fold structure, which is not unsymmetric. Okay. So that d orbital is very close to the nucleus. First s orbital will come, then after p orbital will come, then after d orbital, then after f orbital will come. Means this d orbital or d subshell is close to the nucleus, so that d orbital will experience larger effective nuclear charge. So then after in 3d and 3p, just now I told you S subshell will come first, then after p subshell, then after d subshell. Here why we are considering subshells means here principal quantum number is same. When principal quantum number is same, then we have to take this subshell. So d orbital will come first, then after f orbital will come. So first p orbital will come, so that p orbital will experience larger. So that in this 2s and 3s answer is 2s. In 4d and 4f answer is 4d because d orbital will come. In 3d and 3p d orbital will experience more. 3d and 3p p orbital will experience. So that's why p orbital is answer. Next question. The unpaired electrons in aluminum and silicon present in 3p orbital, which electron will experience more effective nuclear charge? More effective nuclear charge they are asking. So in this aluminum and silicon, aluminum electrons are present in 3p orbital. In silicon, electrons are present in which orbital? The unpaired electrons of aluminum and silicon are present in 3p orbital. Which electrons will experience more effective nuclear charge they are asking. So aluminum atomic number 13. Aluminum atomic number 13. So if you see its electronic configuration, neon 3s2 3p1 will come. 3s2 3p1. And silicon atomic number is 14. Silicon atomic number is 14. Its electronic configuration is neon. So 3s2 3p2 will come. 3s2 3p2. The unpaired electron in silicon will experience more effective nuclear charge here. Why? Because atomic number of the element silicon is more than the aluminum. So aluminum is having only 13 protons, but silicon is having 14 electrons. So means comparing with aluminum, silicon is having more protons. Comparing with aluminum, silicon is having more protons. Where more protons are there more effective nuclear charge will be there. They are asking same orbit, no, 3p orbit. Here also 3p orbit, electron is present in 3p orbit, and here also electron is present in 3p orbital. So but nuclear charge where it is more? So in 14, silicon it is nuclear charge is more. So that's why the silicon unpaired electrons will get more effective nuclear charge. So answer is 3p here. Sorry, answer is silicon here. Indicate the number of unpaired electrons in phosphorus, silicon, chromium, iron and krypton they have given. So phosphorus atomic number is 15. So we can write its electronic configuration neon 3s2 3p5 we can write. Neon 3s2 3p5. Neon 3s2 3p3 we can write. Neon 3s2 3p3. So number of unpaired electrons in p orbital, how many? So this s orbital is paired, so p orbital is unpaired. So then how many electrons will be there? So in number of unpaired electrons in phosphorus is 3. Similarly, you can go for silicon. Silicon atomic number is how much? 14. So here we can get neon. So this 3s2 3p3 with 3p2 will come. Here unpaired electrons are how many? 2. Similarly, you can go for chromium. Chromium atomic number is how much? 24. Its electronic configuration is argon 4s2 3d5. 4s1 3d5 will come. Abnormal electronic configuration. So how many unpaired electrons are there? In s orbital 1 unpaired electrons are there. In d orbital 5 unpaired electrons are there. D orbital 5 unpaired electrons are there. Then total how many unpaired electrons are there? So in d subshell there are 5 shells will be there. So here 1 and here 5. Total how many unpaired electrons are there? 6. Similarly, if you go for iron, in iron if you write electronic configuration of this iron, you will get 4 unpaired electrons. If you go for krypton atomic number is 36. So its electronic configuration is argon. Its electronic configuration is argon 4s2 3d10, 4s2 3d10 and 4p6 you will get. Here unpaired electrons are not there. All are paired electrons are there. So here answer is 0, nil. Thank you.